Hello, and today's purpose of the day is I can divide a polynomial by a monomial and binomial, and I can solve dimensional analysis problems. Let's look at 11.5 dividing polynomials. Let's look at a polynomial divided by a monomial. So here I have 4x squared minus 18x divided by 2x. I can rewrite this as 4x squared minus 18x over 1 times 1 over 2x. And really, all I'm doing is flipping the second fraction when I really divide fractions. So now I want to see how many times does 2x go into 4x squared, and how many times does 2x go into 18x. So I'm going to rewrite this as, first term divided by 2x and second term divided by 2x. And now let's simplify. 4 over 2, I can take out a 2. If I take out an x there, I'm left with 1x in the numerator. Here I can take out a 2 and I'm left with 9. Both x's cancel out. So my final answer here would be 2x over 1 minus 9 over 1, and then there's nothing left there, or nothing left that I need to simplify. I could also have written this problem as 4x squared minus 18x all over 2x, and then looked at, 4x squared divided by 2x and negative 18x divided by 2x that way as well. So I definitely could have rewrote this a different way, just whatever works for you and whatever is easiest for you. Let's look at our second example, 2y squared minus 3y minus 9 divided by 3y. So here I could write 2y squared minus 3y minus 9 divided by 3y. And here I want to see, or I could also then break it down and say, hey, 2y squared over 3y minus 3y over 3y minus 9 over 3y, and simplify here. So let's look. 2 and 3, nothing can cancel out, but with y and y squared, can cancel out there. 3 over 3 can cancel out, y and y, so that just goes to 1. And then 9, I can take out a 3, and that turns to a 3. So then my final answer would be 2y over 3 minus 1 plus 3 over y. And that would be my final answer. Now let's look at a polynomial divided by a binomial. So if we look at our example 1, x squared plus 11x plus 24 divided by x plus 8. So I could really rewrite this as saying x squared plus 11x plus 24 divided by x plus 8. And let's look at factoring. So factors of 24, that when added together give me 11, or 8 and 3. So what this would turn into would be x plus 8 times x plus 3 divided by x plus 8. And then I can simplify terms here. And so my final answer would just be x plus 3 over 1, and I don't necessarily need to write the over 1. Let's look at the second example. So 2r squared plus 5r minus 3 divided by r plus 3. So again, I could rewrite this as 2r squared plus 5r minus 3 divided by r plus 3. And I'm going to use the snowflake method and say factors of negative 6. That when added together, 2 and 2 on top, that give me 5, would be 6 and negative 1. Then I simplify the fraction of 2/6 to 1/3. So what I end up getting in the numerator now is r plus 3 times 2r minus 1 all over r plus 3. Look at simplifying the r plus 3, and I get 2r minus 1 over 1. So my final answer is 2r minus 1. Now we are going to look at some dimensional analysis problems, but we are going to do this with just a little different activity, and we're going to look at the barter system, and barter means to trade. So we are going to think of dimensional analysis problems as trying to trade to get to the end result that we want. So this is going to help us to understand a little bit more about dimensional analysis problems. So step 1 says start by listing the given information at the left edge of the page and the unit of what we want to find at the right end of the page. So the problem that we're trying to accomplish here is how many chickens could we trade for 6 goats? If we know that 4 pigs equals 9 ducks, 1 goat equals 3 ducks, and 2 pigs equals 5 chickens. So we are start by listing again the given information at the left edge of the page and the unit we want to find at the right. So here's our given, and this is where we want to get to. So step 2 then says, then multiply by another fraction based on equivalency provided in the table. Write the fraction so goats cancel out. So again, I'm starting with 6 goats. So 6 goats over 1, because this is going to be a fraction, times, now let's get rid of goats because we want to get to chickens. So I'm going to multiply by another fraction, and where must goats be in the second fraction to cancel out with the numerator from the first? It must be in the denominator. So now if I want to go from goats to something, that's something, I can keep continuing to get to chickens, I could perhaps trade 1 goat for 3 ducks. Again, look up at the table here, and 1 goat is equal to 3 ducks. And again, we want to get to chickens. That's our end result. So now goats would cancel out with, or goats in the numerator of my first fraction would cancel out with goats in the denominator of my second fraction. But now our end result is ducks. But we don't want to be in ducks. We want to get to chickens. So now let's rewrite what we have here. So 6 goats over 1 times 3 ducks over 1 goat. Goats, keep it the same. So goats cancels out. Now let's, multiply another fraction so that we can cancel out ducks. So let's see here. If I look back up at the top, I know that 9 ducks is equal to 4 pigs. So now let's write down 1 duck, or 9 ducks, and 4 pigs. So now ducks cancels out. So now we would have, pigs as a result for our end unit, but we don't want to be in pigs. We want to get to chickens. So step 4, multiply by another fraction so now we can get to our ending unit. So again, we started with our 6 goats, and I'll just rewrite this for this example, times 3 ducks over 1 goat times 4 pigs over 9 ducks. And all these canceled out, right, because they were cross products. So now, let's see here. We want to go from pigs. Is there a unit that we can get from pigs to chickens? You bet, right there, right? So 2 pigs equals 5 chickens. So let's see here. So I'm going to multiply and say 2 pigs is equal to 5 chickens. Now my pigs cancel out because those are cross products, and my ending result would be chickens. Now we actually have to figure out how much it would take to trade the 6 goats to chickens. So now we have to multiply 6 times 3 times 4 times 5, and then divide that by whatever 1 times 9 times 2 is. And our final answer is 20 chickens. That's how much we can get for 6 goats. Now we are not going to go through all these problems on our notes. We might save some for a warm-up in class, but feel free if you would like to go through these, you certainly can. Now we are still going to look at converting from an animal to another animal, or units, and we can use the table above provided. I'll do another example with you right now. So our question is, how many goats can be traded for 18 geese, excuse me. So I'm starting here with 18 geese, and my end result that I want to get to, again, is goats. So I could write that at the right-hand side. I'm just going to write it above so I know that I need to get there. So I have 18 geese over 1 because it needs to be a fraction. Now I want to cancel out geese. So I'm just going to look up at my table and see where I actually see geese. I see geese here, and that's about it. So I either need to go from geese to cows or geese to ducks. Well, let's then look ahead. I need to then get to goats. So let's see if ducks or cows can then get to goats. So it looks like ducks can get to goats there. Looks like, what about cows? It looks like cows really can't be traded with anything, so I don't think I want to go from geese to cows. I probably want to go from geese to ducks, just based on the table that's provided. So 18 over 1. Let's now trade geese to ducks. So I need geese to be in the denominator, right, to cancel out. And then, so that'd be 13 geese, I'm looking at this one right here, is equivalent to 5 ducks. So then the geese cancel out. Now I want to go from ducks to goats. And again, I'm going to use this one right here. I'm going to say 3 ducks is equal to 1 goat. And now my end result is in goats. So now I just have to multiply 18 by 5 by 1 and divide that by 13 times 3. So I get about 2.3. So I'm going to have to round up there to get 3 goats. Right? So if I need to trade 18 geese, I'll receive 3 goats. So that would be the conversion. So again, with dimensional analysis, we're trying to get from one unit to the end result unit. And for the examples that we're going through right now, we are just using different animals and different ways we can trade animals with a barter system that, of course, was made up. So please feel free to go through 2 and 3. The answer for number 2 would be 16 pigs. The answer for number 3 would be 240 rabbits. And again, we will probably go through a few of these in class, but if you wanted to try those on your own, you certainly could. And number 4, if you took the time to go through it, was 192 pigeons. Okay, now let's look at 2 other types of dimensional analysis problems, but without being given a table of values that we can use conversions from. Now, we are going to just use conversions that we know of. So sloths. The slowest land mammal is the 3-toed sloth. It travels 0.07 miles per hour on the ground. What is this speed in feet per minute? So there's a little picture of a sloth right there to show how they travel. So I'm going to start with 0.07 miles per 1 hour, and I need to get to feet per minute. So let's change right now miles to feet. So I need miles to be in the denominator, and I want feet to be in the numerator. So how many feet are there in 1 mile? 5,280 feet in 1 mile. Now, if you didn't know that, that's okay. We'll talk about the different conversions in class. On a quiz or a test, I would give you like a hint if you didn't know that, but it's good to just be thinking about those because you'll see these in many problems, so it's good to practice them. So now I know miles would cancel out with miles there, and now I need to go from hours to minutes. So an hours needs to be in the numerator, minute in the denominator, and this is really easy. We know 1 hour is in 60 minutes. So now the hours cancel out, and my ending units would be in feet per minute, which is what we want from the question. So now I'll multiply 0.07 times 5,280 and take that and then divide by 60, and I get about 6.16 feet per minute. One hour of moderate inline skating burns approximately 330 calories. If Nelia plans to do inline skating for 3 hours a week, how many calories will she burn in a year from the skating? So let's write down what we know and what we're starting with. So we know that she can burn 330 calories per 1 hour. Now we also know we need to get to calories per year, so we can leave calories in the numerator. We don't need to get rid of that, but we need to change hours to a year. So we also know she's skating 3 hours in 1 week. So now my hours cancel out. So now my ending units would be in calories per week, but I want calories per year. So let's see how many weeks are now in 1 year. Well, there are 52 weeks in 1 year, so now I could cancel out weeks, and my ending result would be in calories per year. Now we just have to take 330, multiply that by 3, and by 52, and then divide by 1, because 1 times 1 times 1, and so my ending answer here would be 51,480 calories burned per year. That's a lot of calories. So again, with dimensional analysis problems, we are trying to go from one unit to another type of unit. And we could do this in many different ways. One way is just using rational expressions and canceling out cross products to get to our answer. Thank you for listening. Please check Google Classroom for more information. Have a great day. Bye.